I do not have the ability to access real-time information. This means I cannot provide up-to-the-minute details on events as they are unfolding. My knowledge is based on the data I was trained on, and the data is not constantly updated with live feeds. Trying to access real-time information presents several technical challenges. Firstly, the sheer volume of data generated every second across various sources is enormous. Processing this data in real time requires significant computational power and infrastructure. Imagine trying to sift through a constant stream of information from news sources, social media feeds, sensor networks, and financial markets all at once. Secondly, ensuring the accuracy and reliability of real-time data is critical. Data streams can be noisy, incomplete, or even intentionally misleading. Before any real-time information can be used, it must be validated and filtered to remove errors and biases. This process requires sophisticated algorithms and data analysis techniques. Thirdly, latency is a major concern. The time it takes for data to travel from its source to the user can be significant, especially if the data needs to be processed or transmitted over long distances. Minimizing latency requires high bandwidth communication channels and efficient data routing protocols. In many applications, even a few milliseconds of delay can render real-time information useless. Fourthly, maintaining data security and privacy is essential. Real-time data streams often contain sensitive information that needs to be protected from unauthorized access. Implementing robust security measures, such as encryption and access controls, can add complexity and overhead to real-time data processing systems. Fifthly, integrating data from multiple sources can be challenging. Different data sources may use different formats, protocols, and data models. Combining data from these sources requires data transformation and integration techniques, which can be time-consuming and error-prone. Sixthly, scalability is a key consideration. Real-time data processing systems need to be able to handle fluctuations in data volume and user demand. Designing systems that can scale up or down dynamically requires careful planning and resource management. Seventhly, developing real-time data processing applications requires specialized skills and tools. Developers need to be familiar with real-time programming languages, data streaming platforms, and distributed computing architectures. Finding and training qualified developers can be a challenge. Eighthly, the cost of building and maintaining real-time data processing systems can be substantial. The hardware, software, and infrastructure required to support real-time data processing can be expensive. Furthermore, the ongoing costs of operating and maintaining these systems can also be significant. Ninthly, regulatory compliance is an important consideration. Real-time data processing systems may be subject to various regulations related to data privacy, security, and accuracy. Ensuring compliance with these regulations requires careful attention to detail and ongoing monitoring. Tenthly, the ethical implications of using real-time data need to be considered. Real-time data can be used to track individuals, predict their behavior, and make decisions that affect their lives. It is important to use real-time data responsibly and ethically, and to avoid using it in ways that could discriminate against or harm individuals. These technical challenges highlight why providing up-to-the-minute information is not always possible.